Today we're going to start out with Michael and Ying Su, and with that, I'll pass it over to you, Ying Su.
Gosh, we know each other by first names. Hi,
Oh,
everyone.
sorry.
It's okay.
It's
Cute.
Friday.
Hello, and I'm executive director of Biotech, and Michael Fuller will be also on this talk as well. And Michael, can you share your slides?
Yes.
And happy to not only is today Friday, but it is DNA Day. So we
Yeah.
have everything to do with DNA. So isolate some strawberry DNA or whatnot. So today's talk, we are concentrating on one of the grants that we have. It's really to give students work-based learning, high school students. And we're calling this talk Strategies for Connecting Students' High School Biotechnology Experience to Your Community College Program. So thank you for joining us. So before we start, I just want to give you a little bit of history about this grant that we have and acknowledge Goli Afshar and Karen Zimmerman. It was actually their grant from City College of San Francisco. They couldn't do it anymore, so they asked if we would take it over, and we said yes. So we inherited this grant, and really two of the best parts of this grant are the evaluators that came with it. So thanks to Sandy Mikolaski and Mandri Wijanike, our evaluators. They were there to always listen to us and advise us on our project. And so without them, we could not be thinking about this in a deeper way, and it's just amazing to work with them. A little bit of history about Bayback first is we are a teacher serving nonprofit. I'm the executive director. Michael is the pathways lead. And, in many ways, it made sense for Bayback to take this grant over because I have over 12 years of teaching experience and coordinating internships at a community college setting, while Michael was also a high school teacher, a dual enrollment teacher currently, and very importantly, he was also a principal at a high school. So we kind of understands a little bit of the ins and outs of working with high school and community colleges. And this grant, we wanted to see how we can help high school teachers and community college faculty communicate their pathways better from dual enrollment to biotechnology. So the goal of this grant is to strengthen the workforce pipeline. And the idea is to give students work-based learning, and in such a way that it's having them experience not just working in a lab, but making products that are useful. And if you know us and if you know Bayback, we've been doing this project called Bioscope for some time now. And this project, Bioscope, is the bioscience or biotechnology supply chain operations projects for education. The idea is to have students understand the process of working in a lab, the roles that people have of working in an industry, and having them make something useful or for something for somebody else. It can also be an analytical type of project where you're analyzing something for somebody else. So the aim is to make these opportunities available for students and doing it during the summer and having them get paid, because the students we want to attract and create more opportunities for, might need to have a job at a Taco Bell or something. So we want to give them this opportunity to experience science and doing science, and they get paid for it. They get to do an awesome project and get them more excited about being in biotechnology. During this project, we also recognize that the how has always we always have to think about how is this being done, and it's not just about teaching students technical skills, soft skills. It's really also understanding how programs can work with their multiple stakeholders. And the multiple stakeholders we're talking about here are the high school teachers, the faculty, the college faculty, college counselors, high school counselors, the administrators in STEM, which could be different than administrators for workforce development departments at the college. So basically, we're trying to create a community with shared goals, and with their, keeping in mind that they also have individual department goals that may differ from, or may contradict something that we want to achieve for our students. Next slide. So, very early on, we quickly learned that there was a lot of misalignment in so many areas. So, for example, courses have in this case here, high school dual enrollment courses with the Skyline Biotech department. have different names for these dual enrolled courses. At the high school, it's called 1 and 2, 3 and 4. At the community college, it's called 440 or 220. I can never keep them straight. So starting from that simple idea of having dual enrolled courses, the courses are also named differently to begin with. So students may not even understand that what they're taking count for credit at the community college. So that's a very simple, you know, thing that we found very early on. We also found that recruitment of these students, of any of these students, did not seem to have an intentional focus for biotechnology, meaning that the college is trying to recruit students from high schools, but they may not be thinking about programs that these students could be going into. So I call it intentional focus on biotechnology. So, and in some cases too, and you guys might have seen this, it was very anti-biotech. So telling the students that, oh, don't go into that program because of blah, 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 blah. So they're talking about this in their own programs at their own college. And that was complete misalignment, right? And then the other piece is misaligned goals between what faculty want to do. They want to do train students, provide them with career knowledge, and provide them with opportunity to have these technical and soft skills to transfer and maybe do a earn and learn at their 4 year. Or they can quickly get a certificate and go to a job in biotechnology. So they have these certain metrics that they want to fulfill. But counselors may have a different goal. They want students to come in, get their education, and quickly transfer. So again, a misalignment. So these are the things that we were looking at, that we're realizing, and then we're thinking about how this can change. So what is the problem we're trying to solve here? Initially, it's really about trying to give students more awareness and opportunities in work-based learning. High school students, as we all know, are really difficult to find a internship at a workplace because of liability issues, because of their age, because just a lack of, um, you know, industry people wanting to work with high school students, basically. So what we thought could work really well is a co-op course, or sometimes called work course. Here, they've changed at Skyline, they changed it from co-op to a work. So that's where we're putting it here. It's a course that's held at the college, and students are paid. Michael, go back. Um, and then students are paid to do this course. And it's a nice idea to be doing this at the college, because the students get an idea of what the college is like. They get to, go to the college, go to the classroom, and then also meet the faculty that are teaching the biotech courses. Next slide. So this is a graphic of where the co-op course is shown. So Michael, if you can just circle around where the co-op 670 is with your cursor. It's very upstream of continuing to the college. So basically, the biotech dual enrollment students are getting a chance at this co-op as a bridge before going into the community colleges. And this is a 2-week hands-on course where 4 out of the 5 days per week are done in the classroom. And they have to be there for a full day. So it's like a full job, 9 to 4. Fridays are remote just because the college is closed on Fridays. So they'll do other things like more job skills or maybe a guest speaker, things like that. And and during the 2 weeks that they're there, they're making something that's useful. For example, this last summer, they isolated plasmids, and the plasmids would be used then for Skyline classes. Um, and so how do we do this? So we decided that there's many schools that are actually have a dual enrollment agreement with Skyline. And what you see here on this map, 6 of these high schools are shown. Some are further away and some are closer. So we wanted to make sure that the close by schools are recruited heavily so that they understand that Skyline is much closer, that they can go to the school to have a work-based learning experience. I think this is a animation, Michael. So yes. So just to give you some data to start with, what we call the co-op 670 or work 670. Initially, the baseline that Skyline had, even before the grant was there were 6 that would apply for these work 670 courses and work with Dr. Nick Cap at Skyline. But with the grant, with the heavy recruiting during the first year, we had 71 students apply for 21 spots. The second year, it increased for also another 21 spots. This last year, 39 this year, there was a very intentional recruitment going on for students that are seniors and specifically going to Skyline. So over 2 summers, 44 students from 6 schools participated in our summer co-op project. And I'll leave it for Michael. So Michael, take it away.
All right. Thank you, Ying-Su. Good morning, everyone. Yeah, so after we had our first summer co-op up and going, we wanted to look more intentionally at these students and the pathway. What does the bridge look like from their dual enrollment experience in high school to Skyline? And so we started with this question, well, what kind of information do they have? They are admitted to Skyline as a student. They're registered for the class. The students were familiar with biotechnology high school classes. They thought of them as CTE courses. As Ying-Su mentioned, they had the high school course names, class names, BTech 1 and 2. They were not the college names for these. And most had not been, they weren't familiar with the classes that were at Skyline in the biotech program. So, and I'm also on the leadership team for Innovate Bio. So in conversation with our high schools and our community college programs, this is often what we see. At the high school, students are presented with biotechnology as something that happens at their high school, and these are the classes that they take, right? I'm using a bridge metaphor today. So if we're trying to get them to our community college, they had very little understanding of how this could continue on at their college. So if you go to Skyline's website, this is what they'll see. Right? Here's how you earn your first certificate is these first 6 classes. Here's the AS, right? And what I think we see with a lot of our partners is there is not a lot of, you don't see these two things shown together as a cohesive pathway. You see it as high school and you see it as community college. And so we created this last year or a year before, which is a tube graphic. This is our helicopter view of, okay, dual enrollment at your high school, and what would that look like if you continued on at Skyline? So this is the super helicopter view. And this tube graphic we use when we go into classrooms to talk with students about their options, right? So this is the most common option you'll hear for biotech is earning an AS and a certificate after 2 years and taking those and traveling with them. But we would also present them with other options. Here in California, you can transfer and get a bachelor's degree from community college programs in biomanufacturing. And the theme that I think is important is to talk with them about how your first year could also be part of a transfer plan to a 4-year school. We'll talk more about this later. I'm not going to spend a lot of time on these resources. We've shared them before, but we talked about the relative costs with the students. And then importantly, what would your first year look like at your college, right? So Ying-Su and I will make all of these resources you'll see available today if you want to borrow these and use these for your program. So our second summer, we had 23 students. You'll see that only about a third of them were seniors. So the majority of these students were heading back to high school, right? They reported they had a better understanding of different fields and careers in biotech. The second summer, we offered micro-credentials. They sat for 2 micro-credentials through BCSI, and you can see the students indicated they'd like to continue the opportunity to earn those. And then interestingly, we're finding that work-based learning is a carrot for students. They're interested in it. So we asked them the question, if you were going to come to Skyline after high school, if taking biotech led to an internship, you see the number who would be interested in taking courses was quite high. So after our second summer, we got interested in, all right, are these students going to be interested in actually coming to this? And Ying-Su mentioned this before. So first of all, we found that dual enrollment students in our area, about 65% report that they are going directly to a four-year school. So we already are at a deficit in terms of who we can try and get to the college. Not only are the counselors and the colleges typically interested in a four-year transfer, that's what students are reporting as well. The counselors often don't have a clear understanding of the biotech program, we found. And unfortunately, here in California, articulation of our really skills-based focused biotech classes with the University of California is, I'm going to put this politely, messy. They're not as inclined to give transfer credit, which is a challenge, but something we can work with. So some of the things we did within the grant to address this was we invited counselors from the college to a lunch and learn where we did a basic DNA extraction together and then talked about our program and biotechnology. We borrowed this from Andrea Denman, who's at Santa Monica College, and then tried to be clear with our counselors who are scheduling students, what the course recommendation would be for them. Like, where do we want them to place our students? Interestingly, when we were getting curious about, okay, students who have graduated high school and come to Skyline, we had a conversation with one student. We were certain she was going to do biotech at Skyline. And she said, no, I didn't. Or she says, I'm not sure if I did. And I think this is important as we think about our programs. And she said, because if you're watching the screen here, these are the dual enrollment classes I took in high school. So when I got to Skyline, I only needed 2 classes to earn this certificate. And if you look at both of these classes, neither of them are biotechnology classes. This was a problem because in order to complete the certificate, when she came to Skyline, she didn't need to take any biotech. So I think this points to, just clarity in terms of the pathway and what we're asking of students. So after our first 2 years of the grant, we recognized there was high interest in the summer work-based learning. As you'll see in some data later, students are not interested or much less interested in getting an AS with a certificate. And I know that can vary by area, but it is something that we've seen across programs in my work with Innovate Bio. And in the example I just gave you, the coursework they were supposed to take in biotech after high school was unclear. And there was a interest from students in more work-based learning opportunities. So our next steps were to clarify and communicate how continuing in biotech could be a part of a transfer plan or an AS degree. We're calling this a landing pad course. So what is the clear landing pad course for biotechnology for high school students at Skyline? And then previously, Skyline had an internship program prior to the pandemic. It's clearly something that students are interested in, and we're working with the strategic partnership team at Skyline to revive that. I mentioned working with counselors, and so we started working with Yvette Obeso, and what we did with Yvette was we made a short video, which I've included on this slide here. She and I, it was 2 minutes long, inviting high school students to a flex meeting. In high school now, they have these flex classes. They usually have them once a week. Not all schools have them, but it's much more common. They can get extra help from their teachers, or they can explore different things. And so rather than go out to every biotech class where we know 65% of them are not interested in going to junior college or community college, we invited them to come to us get some pizza, which is important for high school students, and learn about what we started branding as BTech for transfer. So you're coming to Skyline, you're interested in doing science, or you're interested in a biotech degree and certificate, and work with the counselor to start on your plan now. And this would gain you access to our summer co-op as well. So we met with students there, and this is some of the material that we shared with them here. I call this the merge because it has the tube graphic, but then we also drilled down and went real specific on what they're taking at their school. So here's the courses that they take at the high school, and here's the actual units that they're earning at Skyline. So putting it in one place, all right, where they can see it. And then most importantly, all right, after you graduate, what would it look like coming to Skyline? Our landing pad course is this very useful cell culture class, which would be very helpful for setting up for an internship at a variety of industries types. And then you'll see that we have them in an internship prep course. It's only 6 units during their first year. So this provides space for them to take other GE courses. And I think we need to recognize that that's in our example, and I think many examples, that's what students want. They'll continue to have the opportunity to earn these micro credentials. And at the end of their first year, they take Math 200 and Chem 210, which are typically part of a transfer plan. They can earn this certificate. Also, you'll see that this is kind of the inflection point. We want to get them at least started continuing on biotech. They can continue on their transfer plan or the AS or the BS. So this is what we communicated with our students. And we wanted to share just an interesting data point here. We were looking at who's applying for our summer co-ops. And in our first year, you can see that the vast majority were students who were reporting, I'm going to a 4-year school. So the vast majority of students who were applying to this summer co-op were not going to continue on at our college. But since we've been doing this more intentional recruiting, you can see now that the number of students who are reporting they're coming to community college that are applying has jumped up quite a bit. And the number of students who are applying that are going to a 4-year school have gone down. So just to show that we're trying to really focus in on students and be clear about what it could look like to come to the college. I'm going to move past this because I think we're up on time here. One of the things that we learned was there are a lot of different departments at your college who are intended to help you with this work. One of the things we found was they are having what they call the PEP day, where in the spring at the high school, they sign students up for their classes in the fall. And the counselors who were doing that were not aware of our BTech plan. And so we started working directly with them. That's just one example of something that we started doing, which was called an engagement calendar. So we worked with these teams to create a calendar when you're having an outreach event so that biotechnology could have a clear understanding of what we should be doing there. And then kind of our takeaways from our 2.5 years. Hopefully this will make sense, the summary. Our recommendations are to visualize the pathway and focus on choice for students. Clearly communicate how biotech could be a part of a transfer plan pathway or the A and certificate. Explore work-based learning for your high school students, possibly as part of a summer program before they leave high school. And then identify and communicate what that clear landing pad course is at your college for students. Because that's what you're going to want to share with the students, and that's what you're going to want to share with your community college partners, your counselors, and so it's as clear as possible for them. So later we'll share any of these resources that you might need. And I do want to thank the following, way too many folks to thank, some of them who are here, for helping us in our work with this grant.
Awesome presentation, Michael and Sue. Thank you for presenting today. I will like to welcome the next speaker, Louise Petruzzella. She is the Program Director and for Education and Workforce Development at Biomade.
All right, thanks, Cassandra. Thanks to Innovate Bio for giving us the opportunity to show what we've been working on with our current grant. And I believe Haley's got the slide deck coming up. Great, I'll be presenting today. I'll do some introductory comments, and then I'll turn it over to Amanda Rosenzweig at Delgado Community College, who's our co-PI, and Haley Orndorff, who serves as our curriculum developer for Biomade. Next slide, please. Thank you. So just briefly about Biomade, I'm sure many of you are familiar. We are part of the Manufacturing USA organization. We're a Manufacturing Innovation Institute focused on bioindustrial manufacturing. And we're sponsored by the Department of Defense with the following charges here to help commercialization, certainly a focus on supply chains domestically. And my particular favorite is ensuring that we have a workforce that's going to meet the demand, growing demand around bioindustrial manufacturing. Next slide, please. So our current NSF project, we had 3 overarching goals. We definitely wanted to bring together a strong community of practice, which we did by partnering with a number of industry subject matter experts, developing an advisory committee. As Haley in particular starts to talk about the curriculum we've been generating, this has been vetted over and over and over again by many different industry members across the country. And we've been iterating over time as well. So continual improvement, again, with a lot of input from not only industry, but some of our community college educators that have been previewing a little bit of this work over our time. Secondly, of course, we want to get these modules tested. We've been soliciting, again, input, and we keep improving. Haley, again, will talk a little bit about that. And then third, we definitely want to get these out into the community. We have a lot of excitement and a lot of interest from people from the Department of Defense to industry, again, to our community college educators. So we're excited about furthering dissemination of these modules that we're developing. Next slide, please. I'm going to turn it over to Amanda. Before I click off, I'm going to talk at the end again about some opportunities for people on the line to get participate with us upcoming. There are folks on the line too that have already seen some of these previewed materials, so really looking forward to engaging discussion at the end here and answering further questions. So with that, I'll turn it over to Amanda. Thank you.
Hello, everybody. As Louise said, my name is Amanda Rosenzweig, and I am the co-PI of this grant and the Assistant Dean for the School of STEM at Delgado Community College, and we reside in New Orleans, Louisiana. So I'm going to talk a little bit about our role in this grant. So at Delgado, we have a science laboratory technology program, which houses both biotechnology and chemical technology. And we're going to be integrating the new curriculum that Louise talked about and Haley will go into more depth about. And we're integrating this into 7 biotech courses, which is about 50 students a semester, and 6 chemical technology courses, which is about 10 students. And this helps us reach a broader and more diverse group of learners across both disciplines. In terms of faculty development, we've been very fortunate that we've already had 2 instructors trained in the new curriculum with some of the modules. And we're scaling up in the summer of 2025, which Haley will talk about, with 5 to 6 more instructors from Delgado being trained. And what this phased approach allows is a very strong foundation and consistency in the curriculum delivery. So one of the key focus of this curriculum is going to be the incorporation of scaling up from basic lab work and test tubes and flasks to operations involving some smaller and medium-sized bioreactors, because one of the major gaps that we've identified in traditional training is the lack of those hands-on experience with the scale-up processes. So we are been really fortunate to do this. And one of our faculty members is actually integrating a scale-up from test tubes to flasks to 10-liter bioreactors on Monday. So we're going to go through a trial run really soon. One of the reasons we're doing this is because to help provide that real-world context and enhance the hands-on learning, we're also trying to incorporate face-to-face and virtual site visits where students and faculty can actually observe the scale-up processing and gain exposure to relevant equipment, because it's really hard to afford that financially at the community college level. It is just not feasible with space. So this is going to help us bridge that gap between classroom concepts and industry practices. And then we're also really going to focus on collecting student and faculty feedback throughout this implementation to evaluate the effectiveness and identify those opportunities for refinement, which has been ongoing so far. So this feedback loop is very critical in ensuring the curriculum remains responsive, engaging, and is really aligned with what the workforce is demanding.
All right. Thanks so much, Amanda. And with that, I will dig into the details of our 8 modules. As Louise noted, we have had excellent input from an industry advisory committee, an educator advisory committee as well, subject matter experts, and some key themes about the modules and the content emerged early on and have persisted throughout our development. So I do want to hit on those first before we look at the 8 modules. So from the beginning and identifying our objectives and topics to reviewing intermediates of the materials to reviewing full drafts, these 3 elements here have been so important and been good reminders for us. So first is that technicians need the skills to work in both the lab and on the plant floor safely and effectively, especially in bioindustrial manufacturing and pilot facilities. Technicians are working in both spaces, so both at the bench, but also out on the manufacturing floor, working with really large equipment, industrial equipment, and they need to do that safely. The second note is this emphasis on operational skills, right? Particularly at larger volumes, but really this emphasis on what do the technicians need to be able to do, right? Rather than spending extensive amount of time on theory and design of some of these things, we're emphasizing the skill sets, right? Can we get you working, going through these procedures of what a technician really does in their day-to-day work? And finally, we've had just excellent input on the topics, and I'll go through that. You'll see that play out as we look at the modules. So we do have 8 discrete modules. They're designed to stand alone. They're of course related and will have a suggested path of moving through them, but they are complete and will stand alone. Each is designed for 6 to 12 hours of learning time. So most have lab components. So that's about 1 to 2 weeks of your standard laboratory course. And then I'll just tell you a bit more about each module and what we have going on in them. So first is culture, scale up, and monitoring. So this really gives learners this introduction to bioindustrial manufacturing. What is this process? What are you doing in that type of work? And then our activities go from stock to flask, flask to tank, and tank to tank. So we have learners do all of those scale up procedures, and the tank to tank is we have 2 models, a 4-liter model fermenter and a 19-liter model fermenter. That's 1 gallon and 5 gallons. And they are incredibly low cost. The large one, it's less than $50 to construct, but it has, a representative head plate, and the learners can actually practice all of these key skills in transferring and inoculating aseptically. So that's really exciting for us. And then in this module, we also do some of the online monitoring and sampling. So that is introducing them to graphical user interfaces and interpreting these trend and control charts. Next is cleaning and sterilizing with an emphasis on fermentation equipment, so upstream. We have the learners cleaning these two different models, cleaning out of place and actually cleaning in place. Our small model has a working spray ball component, so you can actually model CIP pretty well. And then, of course, we contrast these systems to larger CIP and SIP skids, that's steam in place or sterilize in place skids at industrial scale. Next, we have product separation and purification. So that's our downstream module. Through industry input, we have focused on centrifugation and filtration, specifically disc stack centrifugation and tangential flow filtration, because they are so common in bioindustrial manufacturing. So those are the focus of our practical work. And then we conceptually discuss and expose the learners to some other methods. Next up, we have sample collection and preparation, again, featuring our models. So the learners collect samples from each model, they prepare those and complete assays on them. Another big part of this module is batch records. So we really zoom in on what batch records are, what it means to complete them, exposure to different templates, including industry templates, and giving learners practice working with batch records. In analytics, we discuss the role of analytics, where it comes up in unit operations, going through quality concepts, error mitigation, what it means, to look at your different instruments and what they're able to do in those procedures. So we go through a lot of conceptual work in analytics and apply it all to optical density spectrophotometry because it is cheap and it's available in nearly all two-year classrooms. But we do dig into difficult or more challenging aspects of it in bioindustrial manufacturing. So letting learners choose the correct pipetting technique and tip and working with a viscous liquid and applying all these ideas about quality and error in analytics. Instrumentation and process control. This module can be done completely in the classroom. There are no lab requirements here. So this is really looking at the manufacturing aspect of bioindustrial manufacturing, looking at process control and all of these different elements used to develop and maintain processes. So we have learners going through, identifying these new terms that may be really novel to them, like inputs, outputs, controls in bioindustrial manufacturing, through working with piping and instrumentation diagrams, to process narratives, control loops, sequences, and then even interacting with and trying to manage a free programmable logic controller simulation. And then we have a whole lab on troubleshooting in this one, where they're looking at real or simulated data from industry and a little bit of context and trying to figure out what's going on, just as you would as a technician on the floor. And last, but certainly not least, we have maintenance and troubleshooting. Any practical task that we do in this features either models from other modules or things that, again, are common in a two-year lab, like a biosafety cabinet or hood, or an incubator shaker, or again, any of our models. So we have several tasks focused on doing actual preventative maintenance on these things and troubleshooting issues. And then we, of course, can't teach everyone how to troubleshoot every piece of equipment they might ever encounter, but we can help them develop their own troubleshooting strategies with input from formal troubleshooting strategies like cause maps and 5 whys. So that's the emphasis there. And then last is documentation and safety. This also includes communication and regulations. So this in our suggested flow would actually be the first module, where we dig into standard operating procedures and batch records, how they relate to each other, how you use them. We have a complete asynchronous dissection activity that looks at that. And we also have practical activities for safety and communication that are really fun, but also really put learners into the emotional state of standing up for safety and speaking up for yourself and communicating conflicting priorities, right? And thinking about that in the workplace. So that's everything packed into that one. That could almost be done entirely in the classroom, certainly easily modified. Practice following SOPs is the only lab component to that one. So that is, a look at our modules. Again, our committee has been just so instrumental in vetting everything from the topics and the objectives to the sub-objectives to our design documents, which are this key intermediate, to full drafts. And it's just been so amazing to get their input and examples and support throughout to keep our focus on operational skills and working in both the lab and the plant floor. So with that, I'll just hand it back to Louise briefly to talk about how you can get involved.
Yeah, great job. Thank you both, Amanda and Haley, for joining today. We do have our first NSF ATE workshop coming relevant to this project in June in New Orleans. Haley has the link available for the application. We are nearing capacity, so if there's any interest with you or your colleagues, please apply very soon. And then we'll be at High Tech. Myself and one of my training specialists out of Biomade will be doing a pre-conference at High Tech. And Linnea, to your point, we've got some hands-on activity, but we don't need a lab to teach some of these modules. So we'll be there at High Tech with folks needing to register for that pre-conference workshop. Definitely we'll have presence at the PI conference in October, and then we'll run the professional development workshop again in summer 26 down at Delgado. As Amanda said, a couple of her faculty have already previewed some of the modules and starting to look at putting into their existing biotech courses, which is awesome. In fact, one of Amanda's instructors built a couple of the models already and wants to demo those with her students. So again, really great response from the community up front. There's some overlap from the Northern California project we've been working on, but we'll keep fine-tuning these modules for our NSF project. And prior to anybody really asking, they will be available, of course, for free, widely distributed once we run through our second 2026 workshop. But again, please join us in 25. We appreciate your continued input as far as how to improve, what will work in your classroom with your students, and that's where we're at today. So, and Southeast Community College, Misty has helped us out, certainly Tracy. So we're very excited and grateful again. And with that, I will close. Thank you so much.
Thank you. That's a great presentation. Now we have a few minutes for Q&A. It looks like the questions that have been asked in the chat have been answered. So if anybody else has a question, like to unmute or raise your hand, now would be the time. Tristan. Yes, Linnea.
I think it'd be really worthwhile, since you are planning to do more workshops. You kind of mentioned that for this year, but following years, if you have any dates set or anything like this or thoughts, put it on our calendar, because people's calendar is so full. It's like, I would have gone to yours if I didn't already have 2 things in June.
Thanks, Linnea. We'll definitely do that. We will do, I'm sure Amanda would agree, probably shoot for June again in 26 down at Delgado, but I'll work with Cassandra, Dion, and Sandy Porter to get all that set up for sure.
Very good.
Thank you.
I have one more question if no one else. So of course I do biopharma manufacturing because I'm doing CHO cells. And now I've done algae before, and we might even end up doing mushroom, mycelium. What's the organism you're doing? Is it just bacterial?
Amanda, we're going to try algae down there, and Amanda, yeast?
Yeah, we are doing at Delgado CHO, algae, and yeast. We are not the best algae growers. We're learning as we go because we're new to algae also. But we actually use all 3 in our cell and culture lab, so it's great.
Okay. And I think it'd be interesting to point out what are the differences between biopharma and bioindustrial, because if implement any of this, then I'm going to be very definite about this is this and this is that. Exactly what are the differences?
Yeah, and you know, Ying-Su might be able to speak to this, Jackie as well, who they were with us in California, but our training specialists do an excellent job, Linnea, in teasing those differences out for sure.
Fantastic.
Yeah.
I love it. Any other questions, guys? This was excellent. Both of them were really good. Thank you.
Yes, thank you, Ying-Su and Michael. That was great information being right across the bay for both of you. It's exciting to see your work with Skyline.
Yeah, and Yingsu dropped a link in the chat that'll take you to a little survey. If you do that, it's the short survey, it's basically getting your information. And when you submit it, you'll get a link to a folder. So all of the resources that we shared today, if you want to edit them, they're easily editable for your program. We put them on there, including the video that we made. There's just a bunch of little tools in there that you could adapt and use for your programs if you're interested.
Great.
Does anyone else have something to share about biomanufacturing or bioindustrial? I can see who's on this webinar.